Okay guys, welcome to this quick little tutorial on how to work out this problem that you've been posed with. Let's first of all look at the gear trains and the pulley trains that are involved and work out what the task is actually asking us to do. So if we have a look here, we've got a motor running at 180 RPM, which is connected via an axle to a spur gear, which is also turning another gear here. So here's our first gear train, and it's an 8-tooth turning a 40-tooth. So the first thing I'm going to do is recognise that's one there. And then we've got another axle connected to the 40, which goes through to a pulley on the back here, and then we've got our V-belt or our belt then connected to another one here. And they've given us the size of those pulleys in diameters. This one's 12, we could say millimeters, I suppose, and this one here is 22. So this is smaller, this is larger. And then the axle then comes across through the middle and connects to another drivetrain. This time it's made from gears, and we've got a large gear of 20 then connecting to or meshing with a small tooth of 8. So the first thing to do is to recognize which of these gear trains are actually increased gear trains, which will increase speed, and which ones will reduce speed. Now, if we remember back to our cycling analogy, if I just draw myself a little sort of diagram over here, if I draw a small gear, which represents the gear on the front of my bike, draw a line through it, these represent the pedals, there we are. And then if I would draw a large gear at the back, when we put a chain between those, we know that from our time on a bicycle is about first gear, or it's a reduction gear. It makes it easy to pedal here. This is spinning quickly, this one's not spinning very fast at all. So that's basically what we've got here. We've got a driven gear being the 8-tooth. This is the one connected to the motor. Remember, we always talk about driven and driver. Sorry, this is the driver, mixing up totally. The driver gear, so this is the gear that's actually driving the other one. It's connected to the motor. So the 8-tooth is the driver gear, and the driven gear, the one that's being driven by the driver, is 40. So there's our 8-tooth being the driver, and there's our 40-tooth being the driven. So we'll adopt a bit of a convention here. Let's just draw ourselves a little sort of T shape there. And on the left hand side, I'm going to make a label for this. I'm going to call this one the driven, or another name for the driven might be output. And on the other side, we're going to put another convention for the driver, or the input, or if you like, the power. So if you look back over here, which was the driver? The driver was the 8-tooth, so we put 8 in the column underneath driver. And then the driven was the 40, so we put 40 under or in the column for the driven. So this is a ratio of 8 teeth as to 40 teeth. And we know that it's a reduction ratio because it's reducing its speed that this is spinning at. This is spinning quickly, this is spinning slowly, or slower. Very important to remember that. So we need to simplify this ratio now to make it down to 1 on one side. So if we divide 8 by 8, it turns into 1. If we divide 40 by 8, that obviously is 5. So we have a reduction gearing ratio of 5:1, reducing. We better write that in, reduction. Knowing that, let's go back to our diagram over here, and it tells us that the motor at this point here connected to this axle to here is running at 180 RPM. But after it goes through this first reduction gear, the axle spinning off the bottom or through the center of this one is going to be less. How much less? Well, if we have a look here, we said it was a ratio of 5:1 reduction gear. So that means we need to divide our revs per minute. So 180 is what the motor is currently doing, but it needs to reduce its speed because it's a reduction gear. So we divide that by 5 equals, of course, 30 revolutions per minute. So that means we now have, instead of this axle here spinning at 180, this axle here is now spinning at 30 revolutions per minute. So that's the first stage of the first gear train. The second thing is to work out the second gear train, or pulley train I suppose you could call it. And so we'll do that in exactly the same way. Come across over here. First of all, draw myself a little diagram. Now, is this going to be a reduction or an increase in the pulley train? We've got a small driver and a large driven. A 12 diameter driver, a 22 diameter driven. That sounds like the same diagram we've had before. There's my driver, which is 12, and my driven, which is slightly bigger, is 22. If I draw a chain between them, like my bike analogy, pedal, that's the driver, that's the driven. It's small on the front, it's large on the back, therefore once again we have a reduction. So do our same procedure before, as we did before. Draw ourselves two columns. On the left is the driven, or the output. On the right is the driver, or the input. And let's just put that in there. So the driver was 12 and the driven was 22. Remember, this is a ratio. So let's simplify that. To simplify, to get this down to 1, we divide that by 12 equals 1. Whatever we do this side, we have to do that side. So 22 divided by 12, I think, is 1.8. Sounds about right. So once again, we have a reduction ratio of 1.8:1. So if it's reduction, we have to divide again. So we take the 30 revolutions per minute that was coming out of the axle. Remember, this here is spinning at 30 revolutions, and we divide it by the reduction ratio between the two. So back to here. So 30 RPM divided by 1.8 equals 16.6 revolutions. Oops, where are we? 16.6 revolutions per minute. Okay, so we've done the two drivetrains, one for the gears and one for the pulley. Now let's look at this last one. Okay, so we've determined that this shaft now, or this axle coming through here, is spinning at 16.6, which means this gear is spinning at 16.6, but we've got another gear connected to it, and it's smaller. So let's draw our little diagram again. We've got a small gear, and we've got a large gear. Now I'm going to do it, I'll do it this way. I'll do it this way so it looks fairly similar. I've got a small gear and a large gear. The small gear is the 8 tooth. The large gear is the 20 tooth. But we need to be very careful which one is the driver. The large tooth gear is the one connected to the axle that's spinning, so it's the driver. So we put the pedals on the driver. Now what have we got? Do we have a reduction gear with small driver to large driven? No. We've got now the opposite. Large driver to small driven, which means this is not a reduction gear ratio anymore, but it is an increasing ratio. It's an increase. By how much? Well, let's do it again. Let's put our table over here on our columns. Same convention we had before. The driven, or the output, over the driver, or the input. So a quick check. So the driver was the 20 teeth, 20 there, and the driven was the 8. Once again, simplify. 8 divided by 8 is 1, 20 divided by 8 is 2.5. So now we've got to remember we have a ratio which is an increasing ratio of 2.5, or 2.5 is to 1. So therefore we had 16.6 coming out of that axle, but because this is an increase ratio, it's no longer divide. 16.6 RPM this time, where are we? Multiplied 2.5, because 2.5 was the increasing ratio, which gives us a total of, where is it, 41.5 revolutions per minute. Okay, so looking just from the top again, first thing to do, work out whether it's a reduction ratio or not. Draw your columns, label your columns, make sure they're always the same, driven or output, driver and input. Put your total teeth in, divide the to get it down to 1 on one side of the ratio, and then work out what the ratio is going to be. If it's a reduction ratio, you divide. You do it for the second one, and then if it's an increase ratio, which this time it is here because we know that it's a large driver and a small driven, then it's multiplied by that ratio, 16.6 times 2.5. Okay, I hope that's been helpful, guys, and hopefully you have some success.